Alright, we're going to do number 17 right here. Let's see how this goes. Page 99. Alright. A new battery's voltage may be acceptable A or unacceptable U. A certain flashlight requires 2 batteries, so batteries will be independently selected and tested until 2 acceptable ones have found. Suppose that 90% of all batteries have acceptable voltages. Let Y denote the number of batteries that must be tested. So I guess what they're saying is that Y here is going to be a random variable. And this random variable is going to essentially just take inputs such as, y of, what is it? It would be something like acceptable, right? AA, set AA, and then assign this to a number, which would be, what is it asking for? The number of batteries that must be tested. So this would be 2 batteries tested, and then Y with a simple, set of, maybe the first one failed, but the next 2, my bad, not failed. The first one was unacceptable. It would be UAA. That is a set right here. And from this set, it would say, this random variable would say, okay, then that's going to be, that scenario would be 3. So it's essentially reporting on the size of the set of whatever, situation that occurs. So, so that's what's happening, I think, right here. So, the Y, the range, or what we could get out of that is going to be, 2, 3, 4, 5, ... and to infinity, beyond, etc. Okay. And we're going to assume that we have a 90% of all batteries have acceptable voltages. Okay, and so the probability of in general, of a battery having an acceptable voltage is going to be 0.9. Okay, and then okay. And then probability that is unacceptable is simply going to be that 1 minus 0.9, which is 0.1. Okay. I guess let's just look at A and see what happens here. What is P of 2? That is, what is the probability that the random variable Y is equal to 2? So, in essence, what is the probability of having, this occur? Because there's not anything else. If we have any one of these here, this can be only, U or A, right? So, you can't have any other possible. So it's really asking, the probability that Y equals 2 is really asking for the probability that we have the set AA. Right? And so this can happen if both of them are acceptable, which is the probability of 0.9. So this is going to be equal to essentially 0.9 squared, which is equal to, let me get my calculator. Let's clear it from last time. 0.9 squared, 0.81. Okay, so that's a pretty good probability. It's going to be a 0.81. So I guess that's the answer to A. So this is A right here. This will be our answer. Okay. So let's take a look at B. The probability of P of 3. There are two different outcomes that result in y equals 3. Okay, that's a nice hint. So the probability that basically y is equal to 3. And the two different outcomes that could occur is, well, we already have one of these here. So the outcomes can be UAA. It can also be AU, and then it can't be AAU because AA is just going to stop right there. So these are the two outcomes. So the probability, it's sort of like an inception kind of deal. Okay? We're going to calculate the internal probability of this thing happening within the shot, and then the probabilities of the outcomes happening. So not really pretty, but I want to spend 2 hours on this problem like the other problems. So we have an unacceptable, which is 0.1 times 0.9 squared, and this is going to be like the same, because it's going to be 0.9 times 0.1 times 0.9. Right. So let's see here. 0.9 squared times 0.1. So both of these should be 0.081. 0.081. Okay. So this outcome is 0.081, and this outcome is 0.081, and it's asking for the probability that we get 3. So I guess, and these are independent, so the batteries are independently selected. Try to get some thinking. Do we need to multiply these? No, because that would be the probability of them both happening, right? Yeah, so it would be a union, right? Because we want the probability that either of these happen. Right, so the probability that we get UAA union AUA, right? So that would be an addition rule. Not entirely sure, but let's just go with that for right now. Plus 0.081. And then that would be, they're independent, so we don't have to subtract the intersection. So we're just going to do 0.081 times 2, 0.162. Okay. So the probability of this happening. So my concern is that 181 plus 162 plus 162 is already 0.972. So the probability, basically, I think what this is implying is that the probability that y is less than or equal to 3, it's going to be basically a 97.2% chance. I don't know that. I guess that makes sense. Yeah, I guess that makes sense. Okay. Get the probability 0.9, so that would, a 97% chance seems reasonable. So the answer makes sense, and I think theoretically we're on the right path. I didn't read the chapter, so I don't know. We'll see in a minute. C. To have y equal to 5, what must be true of the fifth battery selected? It's the 4 outcomes for which y equal to 5, and then determine the P5. Okay. So, the probability that y equals 5, and what must be true? Well, the last battery must be acceptable for this to work out. Yeah. Okay, so they're very nice to us because they told us that we have what 4 outcomes, so we have 4 total outcomes. Okay. So I guess let's just determine those sets. So we're just going to write them out because there's only 4 of them. So that's nice. I guess what would have to happen is an unacceptable, 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 and then acceptable, acceptable, right? Yeah. Another option could be maybe the first one was acceptable, and the next one was unacceptable, 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 and then acceptable. A, U, 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 A. Yeah. And then we could have U, A, U, U, A, right? And then finally we could have U, U, A, U, A, and this is 4 different, right? Yeah. So these probabilities are going to essentially come out to be what? It's going to be 3, since these are independent, the multiplication rule for independent events should apply, because the probability of this and this and this and this and this happening, it's going to be all multiplied together. Right, because the probability of A and B happening, that formula is going to be the probability of A given B times the probability of B, but since these are independent, these individual ones are independent, A given B, it's not going to change the probability. It's just the probability of A times the probability of B. So yeah. So that means this is all going to be the same, isn't it? Yeah, that's all going to be the same. It's going to be 3 no matter what. It's going to be 3, what do you call it, unacceptable, which was 0.1 t times 2 acceptable, which is 0.9 squared, right? And then we have 0.1 t times 9 squared. It's going to be 3 zeros. 1, 2, 3, 8, 1. Right. So that'll be 8.1 times 10 to the 4th, which is 1, 2, 3, 4. Yeah. Okay. So this would be. So this would essentially be the probability of each one of these, and we want to know the probability that any one of these possibly happened, that this or that happened. So it would be a union. So so it would be 4 times 0.0081, and this would be equal to 0.00324. That's right. Okay. Let's see, I don't want this one. So D is saying that we want to use the pattern in your answers for part A through C to get a general formula. So we want the probability of Y in general. Okay. So I'm thinking that what we were talking about here, there's always going to be 2 A's. So 0.9 squared is always going to be there. So we're always going to have that 0.9 squared in there. And then the number of 0.1s that we have is likely going to be 2 less than the total number of batteries that we have tested. So here would be just one of the 0.1s, yeah. So I'm going to say, it's going to be 0.1, and then it's going to be Y minus 2. Yeah, I think that's going to be right. Oh, the light just turned out. Let me go turn it back on. I do that sometimes. Okay, so we have this right here, and then we also need to multiply it by Y minus 1. I think that's going to be the trickier answer there. Yeah, because you can see the pattern. You have to cycle through every position. So it's going to be Y minus 1 to cycle through all those positions. So we're going to do Y minus 1. And I think we might actually got it. It'd be Y minus 1 times 0.1, Y minus 2 times 0.9. This kind of reminds me of something called the binomial distribution. We could have to go over that. That's not maybe the next chapter. The values. Yeah, here's the binomial. Would be 1 minus p, so this would be the 0.9, and then the 1 minus p to the n minus x, which would be become yeah, I think this is kind of something out of something. But anyway, let's make sure we got the answer right. So this is number 17 of 3.2. Chapter 3. Okay, here we go. So we got 0.81, 0.162, and then we have 0.1, my bad, 0.00405, which is, what? This shouldn't, It is a yeah, that's what we got, but why do we, it's 0.1 cubed times 0.9 squared. So times 4, did we get this wrong? Zero 8 1 no 0 times 4. What did they do? 0.081 times 5? Well, they multiplied it by 5. But it didn't make sense. For B, we only had 2, and so we multiplied it by 2. This had to be an error, right? Let me look up if maybe, because the previous problem we worked on, it was also an error. Let me pull up on the computer here. Let's see here. I'm gonna pull up. This is statistics for engineering, and the sciences by Duval. 7th edition. Well, if the book wasn't already on its 9th edition, we only have the 7th edition, we would be calling these in, but what do you guys think? Hopefully you're relaxing and not doing the math with me, but I'm really thinking that, I don't know, that I don't think it's 0.00405. It's only 4, so it multiplies it by 4. I'm gonna go with that. We got. I think we're right. So I think there's one more that I wanted to do here. Let's see here. Yes, I wanted to give number 23 a try as well. Just kind of pick these at random. That look fun. On page. Sorry. Page 99. Okay. Here we go. A consumer organization that evaluates new automobiles customarily reports the number of major defects in each car examined. Let the random variable, assuming this is a random variable, X denote the number of major defects in a randomly selected car of a certain type. The CDF, this is a cumulative distribution function of X, is as follows. We got capital F(x) equals, we got 0.06, and for all of this stuff right here. So I'm going to assume so we always want to kind of orientate ourselves with whenever we're given problems. We want to make sure we understand what is action, so just play around with it for a minute. So first of all, we do have a random variable X, and X takes a random variable, take things in the sample space. So, what do you call? Take things in our sample space and assign them a number. Right? That's sort of the big deal with it. Let me double check that. I'm trying to make sure I do it according to the correct notations. Take things from the sample space, and it gives a number to each outcome in that sample space. So the sample space here, without overcomplicating it too much, that's it's essentially going to be something along the lines of, we either have a, we have a car being examined, and we have maybe we're examining 6 or 7, 8, 9 parts. This part is good, this is good, 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 oh, defects, good, dot, dot, dot. Okay, and so what X is gonna do is it's gonna take the input of this right here, good, good, defect, 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 good, something like that, right? And it's gonna output what? The number of major defects. So 1, 2, 3. It's gonna say in this specific scenario there were 3 major defects. Yeah, I think that's what it's trying to say here. And so a cumulative CDF is going to be adding all the probabilities together. So Honestly, X, our range is probably going to be somewhere around, maybe 0, 1, 2, 3, 4, 5, 6, dot, dot, dot. It doesn't tell us, I don't think, how many the maximum is, but we can assume here that anything more than 6, since the CDF is 1, we're not going to get any more than 6, right? So let's calculate the probabilities from the CDF. So A, the probability that X equals 2. Okay, so given that this is a CDF, and we're dealing with inequalities, even though this is a discrete scenario, so kind of weird, but X is less than 0, you're not going to have a negative number of defects. That makes sense. X is greater than or equal to 0, but less than 1. So essentially, this is saying there's a 0.06 probability of having 0 defects. And then from 1 to 2, this is essentially saying that there's a 0.19 minus 0.06 probability. Yeah. And then this is going to be, I think, 2. So the probability, we need this right here. And so when I go from 1 to 2 defects, I jump from 0.19 to 0.39, and that's a 0.2 jump. So this is going to be equal to 0.39 minus 0.19, which is going to be a 0.2 jump. So the probability is going to be 0.2, because that's what was cumulatively added on. So, yeah. Okay, that was A. Let's see what B is. So B is action for the probability that X is greater than 3. Okay, so that's interesting. So that means it must be 4 or more. Right, so let's see here. Here's 4, 5, 6, and 3. So right here is 4, 5, and 6. So the probability of having 4 is the jump from 0.67 to 0.92, which I'm going to use a calculator. Let's save here. 2 minus 0.67, you get 0.25. So, we're going to add up the probabilities. And then we go from 0.92 to 0.97, that's 0.05. And then finally 0.03. So this is going to be plus 0.05 plus 0.03. 0.33. Okay. That's going to be B right there. Okay, now we're getting into the probability that 2 is not going to get X. I'm going to 5. Okay. So, really, so when they say the capital P, what are they talking about? Probability, right? Yeah, so they're giving it the, this is the classic formula here. What is A negative? That's new. A negative represent the largest possible x value that is strictly less than a. What are you talking about? In particular, the only possible values are integers, and if a and b are integers, then the probability that equals a, or a plus 1, or dot dot, or b is equal to f of b minus f of a minus 1. Oh man, what a mess. So interesting. Okay. Because I'm pretty sure we take the integral from a to b when we have this kind of scenario happening with a continuous distribution, but this is discrete. Let me think here. Maybe it'll make sense once we do that. Yeah, so this is basically saying that the cumulative distribution of f of 5 minus the f of a minus 1, so f of 1. So let's just do that, and then I'm going to see where that comes from in a minute. So f of 5 is going to be essentially 0.97 minus f of 1, which is 0.19. So 7 minus 0.78. So that's according to the little formula, but formula doesn't mean much. We don't really understand why it's working. So if we did do f of 2, well, we did f of 2, at that point, it would already have factored in the probability, because this is essentially the probability that we have 2 plus the probability of getting 3 plus the probability of getting 4 plus the probability of getting 5. That's equivalent, but if we do f of 5 minus f of 2, then it would be like getting rid of those 2 and only accounting for those. So I guess, yeah, that makes sense. Something to keep in mind. Okay. Man, that light again. Let me go turn that. Electricity by doing that, but very not fun. Now what about the probability that we have this situation going on? So this is essentially the same thing. It's saying what? The probability, because it's discrete, that this is x, then we go to 4. So it's essentially, f of 4 minus what? F of 2. So it's essentially 0.92 minus f of 2 is 0.39. And so, I wrote that. What about the Okay, if we get these right, that went a lot better than the last few videos that we done on this stuff. But we'll see. So put this here, 123, 23. We got A at 0.2, B at 0.33, C at 0.78, D at 0.53. Okay, I'll take that. Let's get these papers together. Okay. Cool. So we thank you for watching. If you like to leave a comment, leave a like, tell me what you like about it, these videos, what you don't like, because I'm gonna be, sitting here a lot of the summer trying to work through some of these problems. Tell me, do I need to be more quiet? Do I need to do more than one thing or the other? Let me know. Thank you very much, and see you guys soon.